Let's take a look at another review example. What size of an asphalt cast iron pipe is required? So since we were talking about size, diameter, it's case 3 problem. To carry water at 60 degrees Fahrenheit, discharge of 3 CFS, this is our Q, and with head loss of 4 feet per 1,000 feet of pipe. So this is HF, and this is the length of the pipe. Perfect. Now, this is case number 3 problem. So we have all the other information except for diameter, and also it's called design problem as well. What I'm going to do is, first of all, based on what's been given to me in the problem statement, go to table 8.5 and 5 kinematic viscosity at 60 degrees Fahrenheit, which is equal to 1.22 times 10 to the power negative 5 meters squared divided by second. And then also go to table 10.4, and for asphalt cast iron pipe, K sub S would be 0.004 or 0.005 inches. These are the information that I can get based on problem statement. Now we're going to calculate the diameter of the pipe. So what I'm going to do is write down the Darcy-Weisbach equation, and Darcy-Weisbach equation is equal to HF is equal to F, length, diameter, velocity of water in the pipe to the power 2 divided by 2g. And then what I'm going to do, instead of velocity, I'm going to replace it with Q divided by area and write it down. So it would be F, length, diameter, Q to the power 2 divided by A to the power 2, 2G. And again, I can even simplify it further and write it as, or let me write everything together, not in separate fractions. So it would be F, L, Q to the power 2 in the numerator, and 2G, and then area would be pi over 4 to the power 2 times diameter to the power 5. All right, so this is HF equation. Now what I need to do is solve for D. So I'm going to solve this equation for diameter because that's what I want to find. So diameter to the power 5 would be equal to F L Q to the power 2, 0.785 to the power 2, 2G HF. So in this equation, obviously we don't have diameter. Also, we don't have value of F, right? But what we have is length of the pipe. We have Q, we have G obviously, and we have HF. So we have 2 unknowns and 1 equation. Obviously, there should be some guessing involved. I'm going to call this equation star. And what we need to do is first guess an F. And then once we have F, we can find diameter. Once you have diameter, you can use flow equation or Q divided by A to find velocity. And once you have velocity, you can calculate Reynolds number. Once you have Reynolds number and you have D, you can calculate K sub S over D and go to Moody and find new F. and then compare this f to this f. If they are equal or very close, perfect. If they are not, and then you need to guess again. Notice that since we do not have, for our initial guess for step number 1, since we don't have K sub S over D and we don't have Reynolds, we cannot use Moody to provide an initial guess, okay? So our guess is a little bit more of a wild guess type. So I'm gonna name these steps first and then show you how to move forward. All right, so my recommendation whenever you have a problem like this is to form a table. That table is going to help you to organize your calculations, and because you're going to have more than one iteration, it will help you to organize the paper and your calculations. So the table that I would recommend will have 1, 2, 3, 4, 5, 6, 7 columns. Column number 1 would be iteration number. So iteration number is column 1. Column 2 is initial f. Column number 3 is diameter, or D. Column number 4 is velocity. Column number 5 is Reynolds. Column number 6 is K sub S over D. And the last column is nu F. All right, let me make these in this table a little bit more organized. Give it some table look. All right, so you notice that the columns are basically the steps that I need to take, right? So I'm going to start with my iteration number 1. So your initial f should be an intermediate guess, an intermediate guess. An intermediate guess is something between 0.01 to 0.025. I'm going to go with 0.015. Okay, so this is basically, just to tell you, this is step 1, step 2, and then, sorry, the step, if I want to be consistent with the red step, this is step 1, step 2, step 3, step 4, step 5, and step 6. Okay, now, step 2, I need to find D. I just need to use equation star, this equation, to find diameter. And if you find diameter, and what would be the unit for diameter? It would be feet. If you find diameter, it would be 0.968. 0.968. Next, you need to find velocity. How do we find velocity? Velocity is Q, which we have the value for, and divided by area. Now that we have D, we can calculate area as well. So I'm just going to write the final answer for velocity. Let me tell you that the unit would be feet per second, and the value for the given D would be 4.08. 4.08. Then Reynolds number. Reynolds number would be 4.3. 4.3 times 10 to the power negative 4. Now, K sub S over D. We already have the value of K sub S. K sub S divided by D would be, all right, so I messed up over here. K sub S over D is 4.3 times 10 to the power negative 4. Let me change it over here. This is 4.3 times 10 to the power negative 4. And the Reynolds number, based on my notes, is 3.26. 3.26 times 10 to the power 5. There we go. Now it makes sense. And if you go to Moody diagram in step 6 and find a nu F, you will find that nu F is equal to 0.0178. So Now, our initial f is not equal to new f. So what I'm going to do, I'm going to use the new f, 0.0178, as my second guess. And then do the same thing. If I put this f into a diameter equation, then diameter would be 1.002, velocity would be 3.81, Reynolds would be 3.15 times 10 to the power 5. K sub s over d would be very similar, 4 point this time 2 times 10 to the power negative 4. And then the new f would be 0.0178. And you can see that it converged really, really fast. Now, if you keep doing this, if it's not equal, you will put this over here and then calculate the rest. If it's not equal, you'll put it over here and do the same until they are equal. But since right now this value is equal to this value, I'm going to accept it and move forward with my calculations. So I'm going to say that the pipe that I'm going to design for is going to be 1.002 feet diameter. However, because no manufacturer is going to manufacture a pipe this big, right? Because take a look at the digits after the decimal point, right? So we are going to, because no manufacturer is going to manufacture such pipe, we are going to recommend the closest round pipe, the closest possible, which would be 1.00 feet. And that would be our recommendation for the pipe size, and this was a design problem.